if you look at the fuel rails, these are our billet fuel rails that we've produced for these cars. They look fairly simple, but they're a little complex because the injectors are on a compound angle, so they're canted both outward, but they're also canted in towards each other. So those make those fairly difficult to manufacture, but it's part of our flex fuel system for these cars. You'll also notice we've got 2 Kinsler regulators that are custom modified. The car actually has a Kinsler Tough pump, which is a mechanical racing fuel pump that is on the back of the factory oil pump. So anytime the car is running or driving around, it is running on solely the mechanical fuel pump. And that's what just allows us to have the volume that we need for running higher percentages of ethanol and or running straight methanol. So the car is a true flex fuel car now. We have the ability to run anything from 93 octane all the way to E100. And then we can also drain all that out and fill the tank with straight methanol and run pure M1 methanol in the car.
And the car will know the difference.
The computer will know the difference because of the sensor that's on the firewall.
And it'll make all the boost
It'll do all the
adjustments.
changes for the fuel percentage content based on the boost control, the allowable boost that the engine's allowed to make depending on the fuel percentage that it's on. Obviously alcohol is very good for thermal management. Some of the other things that we've done for thermal management is, if you look at the exhaust system, it's a custom 321 stainless steel exhaust. And it has a plasma flame spray deposition coating on it, which is one of the best coatings that you can put on exhaust system. We have over-temped and burned off just about every ceramic from all the top manufacturers that you can think of. And the plasma flame spray deposition coatings are the best that we've found for reliability and longevity on the exhaust system. But even with that good high temp coating and being good 321 stainless exhaust material, on a 70-degree weather day on a drive cycle test, we found that the frame of the car after a 1-hour drive cycle would run 220 degrees Fahrenheit. So we decided that we'd do the thermal management with the shields. The shields are actually Inconel. They're 2 layers of 40 thousandths Inconel with a thin ceramic blanket between them. And what they are is a physical radiation blocker. So if you imagine the exhaust system were like a fluorescent light bulb, anything that would get direct light is also getting bombarded with direct thermal radiation. And that's the majority of where this heat transfer, this heat energy is coming from and how it's being transferred to the parts in the vehicle like the frame. So by putting the shields over the exhaust, we're actually creating a physical blocker that blocks that thermal radiation. And the benefit of that is on the very next day when we put the shields on, did the exact same test cycle on the 70-degree weather day, we found that the frame temperature was 110 degrees Fahrenheit. So we actually took 110 degrees out of the frame of the car by shielding the exhaust system. So that's pretty massive for thermal management, especially considering things like this. We needed a place to put ice water for the intercooler. So with the crossover being in through here, we could no longer utilize the factory cross member, and we had to design a new one. I also needed a place to put water, so we decided that, hey, let's make the cross member our water tank. So this is a 10-gallon ice water tank. It's all sheet metal. It does have structural components in the middle of it. It is still our transmission mount, but it gives us quick access to be able to get in, add ice and water when we need to for the intercooler. It is also isolated from the frame. The frame does run 110. We don't want our water at that temperature, so we do have a phenolic spacer between the cross member and the frame as well. We run a big 55-gallon billet water pump that provides all of our water to our intercooler. It flows through soft lines for flexibility to the back, into the intercooler, out the front through hard lines, just because there's no room in the front for spacing. So the top actually everything in the system is designed to self-purge. So if you notice here, the tubing at the top, which are the outlets of the intercooler, are on the high side to purge any air that's in it through the system and out. And it's also at the front for our outlet because as you accelerate, all the water is going to move to the back. The lighter mass, which is your air bubbles, are going to move to the front, and that's why we discharge out the front of the intercooler.
Makes sense.
Things like our water tanks here, we actually found that Moroso is the one who designed the tanks originally for Ford, or build the tanks for Ford. So they actually had a spare set on the shelf that we're grateful that they provided that to us. So we made this custom. It's got our recovery tank in it here, which is overflow. We put normal radiator caps on them. As everybody knows, the GTs, when they overheat, they blow water everywhere. So we put a normal cap on it with a discharge to a recovery tank. That way we're actually not blowing water if it does get hot all over the engine. And then this one actually goes all the way down the side of the car and back up to the front windshield. So if it ever were to overheat or blow water, it'll blow it right up on the windshield so that the driver can see it. We've incorporated our breather system into it also. We've got dash 16 lines with our custom brackets on the valve covers, just to make sure that the engine has proper and adequate crankcase ventilation. The vehicle now has a full Motec system on it. We've already kind of showed you the keypads associated with that, but here's the ECU. This is a Motec M150. It's actually got our custom development license in it with our custom firmware specifically for the GT platform. We've added a PDM15, which is a power distribution module. You'll notice there's a power cable coming in right here, and this is doing all of our power supply. It's all a solid state relay with logic control. So it's actually communicating with the ECU and the keypad inside the car, and this handles all of our fusing, all of our relaying, basically all of our logic control for when we want certain items to be powered or not powered. So that's all handled out of the power distribution module. And if you'll notice, we also have expanders in the back. This is an E816, so it gives us 16 more inputs just for the amount of sensors we have on the car. If you were to look around the car, you'll see that there are actually sensors everywhere. We're monitoring things like coolant pressure, just helping monitor the health of the engine. Here are the case temperatures I was talking about earlier, looking at the case temperatures of the blower. We're actually monitor pressure and temperature inlet to the blower and pressure temperature out of the blower. We monitor air temp and pressure into the intercooler, which are kind of tucked back in underneath that you can't see very well. Also on the discharge side, we're basically looking at all of our differentials across the car. You'll see things like pressure on our nitrous solenoid. So this one's actually our nitrous solenoid, this one's actually our purge, but it's all flowing through it. And this is actually just monitoring the line pressure. So if we see the line pressure fall off, we can modify the fueling for the motor. If we start seeing bottle pressure drop or something to that effect. There's a lot of sensors on the car, and we're monitoring and doing quite a bit with all of it. Another device that's on the car is our M&W ignition system. So we're running a CDI ignition, which is a very powerful 250 millijoule ignition system, and that's basically just because of the boost level we're running and the amount of alcohol content that we're running.
So that's something like 1.21 gigawatts?
Something like that.
Yeah, ooh,
Yeah, 250
that's
millijoules.
dangerous. So, you know, the question everybody asks, how much horsepower does it make?
So we've got a range of horsepower it's going to make depending on the fuel it's on. We're looking at just over 1,000 horsepower on pump gas at the wheels. We're in the neighborhood of 1,600 on a high percentage of ethanol, and the system will support right about 2,000 horsepower on methanol.
2,000 horsepower. All right. Well, you wanna hear a swarm of bees attack?
We can fire it off.
Let's start it up and then shut it down and explain the noise.
She's loud.
Yeah, she does.
What you're hearing there is probably the biggest question we get is we have people, we took it to the SEMA show and we got just an enormous amount of attention. Anytime we start the car up, there's an enormous crowd around it. And most everybody really dug the sound. Most everybody would make comments that that is the craziest thing I've ever heard. I've never heard a car that sounds like that. But it's definitely polarizing. People either love it or they hate it. We do have the ability to run it wide open, which is what we have right now. So what you're hearing is you're hearing the wastegates that are wide open, and you're actually hearing the discharge pressure out of the screws. So because the gates are open, because the throttle's shut, you are hearing that pulsing sound of the pressure waves coming out of the screw supercharger is what you're hearing. So this is what we refer to as blower whine. Guys that are used to being at the racetrack, being around big screws, anybody you've seen run big screw compressors or even just normal paddle blowers, you'll hear that blower whine that's famous for that. Typically you hear those when the throttle's open. That's when the scrolls are the most easily and audible heard, when the throttles are wide open. In this case, because we have the wastegates at the bottom, you hear a little bit of the whine. We hear a decent amount of the whine at idle. But then we also have the ability to come in and build a muffler system for these, will quiet it down. So it just depends on the customer, what they want, what they like. It is very loud when it's not muffled, but it just depends on what you want. It's different, and again, it's interesting. It's come out significantly different than the way most supercharger systems are built, and we didn't really set out that way. It wasn't like, hey, let's go make something totally unique and totally different just for the sake of being different. That wasn't at all what the goal was. The goal was to manage and handle the thermal aspects and the downsides to screws with the amount of heat that they generate. And this system's done that extremely well, and these are just some of the byproducts of that. So this is what has to happen in order for the system to run cool. And then, like I said, for somebody that wants it muffled down and quieter for street operation, maybe not draw as much attention, that's something that we do. We just go in and build a muffler system for it.
So basically, this is a car built to make turbo power, but have the supercharger response that's so much fun driving around the street.
Right. The overall fun drivability factor.
Very, very impressive.